select statements and insert statements. Yeah. All right, the first topic, 8.1, resolving ambiguity in select statements. Yeah. So now we need to add, some detail features. Yeah. All right. First, so let's look at a simple question first. Yeah. Handling ambiguity. Let us use a simple example to see. So what is the ambiguity here? Okay. All right, the question. Yeah. Here I still use the company database. Okay, yeah, so I already posted. Yeah. Company database. All right, yeah. For every project located in Stafford project, one of the 6 tables, we have a project table. Yeah. Location, Stafford location. Yeah. This, the project number, the controlling department number, and the department manager's last name. Yeah. So here you can see at least we need 2 tables, right? First, we need a project table, so we can get this project related information. We also need a department table. Department manager's last name, but the department table does not contain the last name of the manager, right? Yeah. So you need to be familiar with those tables here. Yeah. Based on my understanding, so no last name in the department table. So the last name is in the employee table. Yeah. So you have to go to the employee table to retrieve the last name information, right? So here you can see we need 3 tables. We need 3 tables. All right. All right. So this time we need to join 3 tables. 3-table join. Yeah. Okay? Yeah. All right. Before we do that, we did 2-table join. Yeah. So we learned the concept, the general idea. But we can extend our understanding from 2-table join to 3-table join operation. Yeah. Here, let me just review high level a little bit. Yeah. 3-table join. Yeah. Remember 4 standard steps, right? Yeah. Our 2-table join, we have 4 standard steps. Yeah. Now, let's do 3-table join, and we do 4 standard steps, understanding the whole process. Okay, all right. ABC, 3 tables. A table, let's say that's our project table. Project A table. B table, department table. C table, employee table. We need to join these 3 tables. All right? Yeah. The first step, remember, we do not consider the condition, where condition. Yeah. So here, look at the condition part. Project located in Stafford. This is a selection condition. Yeah. It's not a join condition. Okay? The join condition hidden. Yeah. The join condition, we need to find the join condition based on our observation on these 3 tables. Yeah. All right. Yeah. So the select condition, the hidden join condition, but we can find out easily. Yeah. All right. Then the first step, we do not consider any condition. We just do the Cartesian product on 3 sets or multi-sets. Yeah. We do A cross B cross C. Okay? Yeah. A cross B cross C. Yeah. How to do that Cartesian product? Yeah. Here, let me review another time. Okay? Yeah. how to do Cartesian product. All right, so for A table, let us use Si to represent the tuples in A table. Now, B table, let us use T, J. All right, tuples. All right. The third table, C table, let us use RK, tuples. Okay? Yeah. Then, when we do Cartesian product, you form a larger tuple. So you use these three different types of tuples to form a larger connected tuple in this way. Okay? So one tuple, the first part you use Si. Second part you use T sub J. The third part R sub K. Yeah. So that is the form of the tuples in A cross B cross C. Yeah. But you need to, you know, the DBMS, yeah, so here I say you, but DBMS will do that. The DBMS will form all possible tuples. Yeah. So you know the number, right? Cardinality, you know, when we calculate cardinality, the product of cardinality of A times cardinality of B times cardinality of C. Okay? Yeah. That's step one. Okay? Yeah. Step two, then we apply the join condition. Yeah. Here, join condition, I want to show you the, you know, the code, the SQL command. Yeah. All right. Yeah, so here, let's look at the, you know, join part. Yeah. So these three tables. From the SQL command, let's look at the join condition part. This time we need a two join condition, right? Yeah. Between two of the table, we need a one join condition. If we want to join another table, we need a second join condition. Then we can join all three tables as a larger table. Okay, as a larger table. Yeah. All right. Yeah. So let's look at the SQL command. Yeah. Let's look at the join condition part. Wait, two join condition. Yeah. So first the join condition, second join condition. Okay. So let's understand. The first join condition first. Second join condition. The first join condition, denom. Denom is a field inside project table. Denom. Okay? Department number. Also department number. But we intentionally make it different. Yeah. Because in employee there is a department number column. We call it a DNO, right? DNO. Here you can see the same object, the department number. So here let's call it some object. The same object that in three different tables, we use three different names to call the same object. Department number, in the department table, we call it a D number. Okay? In the project table, we call it DNOM. All right? Then in the project table, we call it DNO. Here, see? Yeah. The reason, simple, like this, because we do not want to get confused. We want to, you know, using these three different names to tell us which table we are using. Okay? When you talk about DNOM, yeah, we know this comes from the project table. Yeah. When we use the D number, we know it comes from the department table. Okay? When we use the DNO, we know it comes from the employee table. Yeah. Things like that. Okay? All right. Yeah. But still, yeah, some of you may still you have question. How do we know it comes from project table, department table, employee table? Yeah, you need to look at your table definition. Okay? You need to look at your table definition. Yeah. So that's one thing, but there is another thing. Yeah. I will talk about. That's the topic of this 8.1, ambiguity, right? Here, there is ambiguity here, right? So we need to resolve that ambiguity. Okay? Yeah. So that's the topic. Yeah. In this part A, 8.1. Okay? All right. Yeah. But here, you just know, let's apply these two joint conditions. Yeah. Let's apply first joint condition. Yeah. Let's delay that ambiguity question. Okay? Yeah. Later I will come back. Yeah. But here, yeah. Denom long, because you have large number of tuples like that. Okay? Yeah. Large number. Yeah. You imagine you want to go through all these tuples one by one. When you examine each one, first you check the first joint condition. If denom equals d number, well, the value, because they are all there. They are all there. You just compare these two columns and see if these two columns have the same number. If this condition is true, you keep it. If it's false, eliminate. Okay? Eliminate that tuple from the Cartesian product big table. So your starting point is a big Cartesian product table. Okay? So this big Cartesian product, that's your starting point. Now, when you apply each condition, you cross out all those tuples that do not satisfy that condition. Yeah. So here, the first condition, yeah, you apply denom equals d number. If it's false, cross out. Okay? True, yeah, keep it. Then the second condition, yeah, you have a department manager. Each department manager has a SSN number. Yeah, so there is a field called a MGR underscore SSN. Okay, so that number should be the same as the SSN in the employee table. Okay, yeah. So yeah. Now you check, you compare the values of these two columns in your big Cartesian product table. Okay, if when you compare these two fields, if they have the same value, you keep that tuple. If not, cross out. Okay? So the second round, you eliminate certain number of rows. Yeah. Then last round, you apply this is selection condition. P location, project location. Okay? Each project, in the project table, each project should have a location under this P location field. Now the selection condition. If the P location value is this stafford, then you keep it. Otherwise, cross out. Okay? So you cross out certain number of rows in these three rounds. The first round, D number, that round. Second round, SSN round. Okay? The third round, this location round. After these three rounds, crossing out. Okay? Yeah. The remaining rows, that's the query result of this question. Okay? The 4 steps. Yeah. Standard 4 steps. Yeah. Cartesian product first step. The second step, the joint condition step. Yeah. Here we have 2 joint conditions. Okay? Yeah. So you need to apply two joint conditions, the second step. Third step, selection condition, yeah, that P location. Fourth step, yeah, I haven't mentioned that fourth step, projection step, the last projection step, right? Projection, because we need the information, project number information, that's in our projection, yeah. Controlling department number, yeah, denom, that information in our projection. And department manager's last name is also in our projection, okay? Yeah, so here you can see P number, D num, and the L name. Yeah. All right. Yeah. That's the understanding of the three table join. Okay. Yeah. Yeah. That's how DBMS does in the, software internally. Yeah. The processing details. Yeah. So that's our understanding. Okay. Yeah. So after you have this background, yeah. So then when you work on your own query questions, yeah. So basically you follow this kind of logic. Okay. Follow this kind of logic. Yeah. All right. Yeah. So that's one. Then the last thing, after we finish this table job, the last thing is the ambiguity question. We need to, because when we write our SQL statement, we want to write it in a good way. We want to write it in a good way. So what is the good way? Yeah. Here, after we write it, we want to make other people understand easily, right? Yeah. Also, for ourselves, we want to make it easier for us to understand later. Yeah. Because sometimes if you write it in a bad way, later after some time when you come back, you could understand the meaning. Yeah, because you forget how to write the statement, right? It's possible, yeah. Although it is written by you, but you forgot the logic, right? How did you write it? You forgot the logic. That's possible. So for this kind of, in order to avoid things like this, yeah, we want to write it clearly with good readability. Yeah, so here we emphasize the readability issue here. Yeah. Make it more readable, yeah, easier to understand. So here the main thing is we need to resolve the ambiguity. Yeah. Yeah. There are, several, yeah, because here there are three tables. Something that's not that easy. How do you know which column comes from which of the three original tables, right? Yeah, it's hard to memorize. Although you can go back to look at the code. Yeah. Yeah. But if we can associate each field to one of the three original tables directly, they're more readable. Yeah. Yeah. So here, that's what we are going to do. Associate all the fields to their original tables. Okay? Yeah. They're more readable. Yeah. But next question, how to do that? Right? So how to do that? Yeah, that association. Yeah. All right. So let me use a few steps to do that. Yeah. There are several ways we can do that. Yeah. But later we want to find the best way. Okay? Yeah. All right. The first way. Yeah. We want to do it. Yeah. First try. Associate each field name to its original table name. Yeah. Straightforward association. Okay? You do not do anything special, just straightforward association. Yeah. Add the qualifiers using table names. Yeah. Project table, you just write the project table name as the qualifier for that field. Yeah. All right. So here, let's look at when you need to write P number, you need to use the table name as the qualifier. Yeah. Yeah. For every field, you need to write the table name. Yeah. That is clear. Yeah. But the problem, yeah, definitely you can see the problem. Yeah. Yeah. You need to type too much, right? So each table, you need to type the full name of the table. Yeah. Yeah. So this first try is not very efficient. Not efficient. Okay? So we want to improve it. Yeah. We don't want to type so many characters. Yeah. We want to save some keystrokes. But we can still make that, table name information, association clearly. We can still do that. Yeah. So that's the next, we call the alias-based solution. We need to use the alias. Yeah. In Unix, the alias. Yeah. Here, yeah, alias. Yeah. All right. Each table, you define an alias for each table. Yeah, much shorter. Okay. Yeah. Then you just use alias to be the qualifiers for those tables, for those three tables. Okay. Yeah. So the solution is very simple. Yeah. Read each table name to avoid repeated type long table names. Yeah. An alias can follow the keyword as. This as is the keyword. Okay? As. You use this as keyword to define alias. Okay? All right? Or it can directly follow. Yeah. This as keyword can be omitted. You do not have to type as. Okay? Yeah. Omitted. Yeah. Because the meaning is clear. Okay? So you can say a little more. Yeah. Omitting this as keyword. All right? Yeah, these two ways. Yeah. Yeah. All right. Then look at the example. First, in the from block, we define aliases, three aliases. Okay? The project table as P. Okay? Yeah. So P is the alias of project table. Okay? Department table as D. Yeah. So you define the alias. Yeah. Employee table as E. All right. After that. So everywhere where you need to refer to that particular table, just use its alias. Yeah. Yeah. That's the straightforward solution. Okay. Then it's so clear. All right. Yeah. So clear. Yeah. But at the same time, you know which table you are using. Yeah. So no confusion. Yeah. Yeah. All right. So this looks a good solution. Yeah. This way. Yeah. So it's a good solution. Yeah. This alias way. Yeah. All right. Yeah. Then yeah. All right. Right. So here another question. Yeah. Yeah. Based on the rule above, all these as can be omitted. Okay? Yeah. Yeah. If you like to save a little more, you can omit these three as. Yeah. Yeah. Project P, comma, yeah, space. Yeah, space separate that. Yeah. So it's no problem. But yeah, here one idea I want to I want to convey here. Yeah. So, although, by the rule, these as keywords can be omitted. Yeah. But many people, they still want to keep the as keyword. Okay? Yeah. For better readability. Okay? Yeah. As to separate. Yeah. Because if you remove as, although you can define alias, but not stand, things not stand out clearly, right? Yeah. Yeah. So if you use as, so as separate, table name, alias, so yeah. So for better readability, yeah. Some people, not all, yeah. Some people they like to keep the as keywords. Although you need to type a little more, but you want to, put the readability in a higher priority. Okay? Yeah. So yeah. Yeah. Sometimes we are willing to do a little more to get a better readability. Yeah. So that's another commonly used way, for the programmers. Yeah. Yeah. All right. There is another situation. 2 different copies for same table. You need to use the same table twice. Same table twice. Yeah. All right? For example, employee table. You need to use it for employee. That's once. Another time, you need to use it for supervisor. Supervisor information also stored in employee table. But you want to extract the supervisor information, so you need to use 2 copies of the same table. Yeah. So here, let's talk about that special situation here. Yeah. Same table, 2 copies. Okay. This time you can see the alias is important. The alias is important. Yeah. Otherwise, if you do not use alias, then you have some big trouble in the ambiguity thing. Okay, resolving the ambiguity. You have some big trouble. Yeah. All right, let's look at an example. Yeah. Yeah. This time you cannot omit that alias part. Okay? Yeah. All right. Look at this example. Yeah. Supervisor. All right. So here, yeah, I didn't give you the question statement, but we can understand the question requirement easily. So that is, we need to, for each employee, we need to list the employee name and its corresponding supervisor's first name, last name. Okay? Yeah, that's the question. Yeah. All right? Yeah. Here you can see this alias is very important. We use employee table twice, but the first time we use E as the alias. Employee copy. Okay? Then employee table, the second copy, second time, this time we use alias S. Yeah. So it is used as the supervisor copy. 2 copies, employee copy, supervisor copy. Okay, all right. Yeah. So here the concept, no problem. Concept, same table, 2 copies, they can be joined. Yeah. One table join itself as different copy. Definitely, it's a different copy, but joined together. Yeah. So in math, it's also allowed. Cartesian product A cross A. That's okay, right? Yeah. Cartesian product, yeah. Yeah. A set. We can use it to do the Cartesian product with the same A set. Yeah. No problem in math. Yeah. Here, yeah, we can do that. Okay? Yeah. For A set, yeah, the first copy. So if we use the, TI, yeah, representing the typical tuple. Yeah. Then, second, a different, different copy. Yeah, but here, if you use the, TJ, it's still okay. Yeah, because same table. Yeah, so that's. But the subscripts, we use different subscripts. Okay, I subscript, J subscripts. Then the tuple, when you join them, the first part, Ti, second Tj part. Yeah, no problem. Okay, well defined. Yeah. Okay. Yeah. So here the join condition. Employee table E dot super underscore SSN. Okay? So there is a field in the employee table super underscore SSN. So this employee, so that field stores the SSN of the supervisor of the current employee. Yeah. So that one should be the same as the supervisor's copy of that employee table dot SSN. Yeah. So, yeah. No confusion. Yeah. Yeah. All right. So that's a special case. Yeah. All right. Yeah. All right. So that's the, our first topic. Second topic, 8.2. Set operations on queries. Yeah. Set operations. Yeah. Yeah. In math theory, we are familiar with some commonly used set operations, right? Yeah. So here we can, extend that understanding to our SQL queries. Yeah. All right. Let me, check the time. Yeah. All right. All right. Yeah. So let's look at this topic. Using set operations to represent queries. Yeah. All right. Borrow from mathematical set theory. Yeah. In math, there is a set union operation, right? Set union. You know the meaning, right? Set union. Yeah. So here in SQL we use this union keyword. Yeah. Union keyword. Okay. Yeah. Set A union set B. Yeah. Yeah. And in math we use that union operator symbol. Okay? Yeah. A union B. A union B. All right? Yeah. All right. The second one, set difference. Set difference. We have set difference operation, right? In set. Yeah. What's the set difference? Yeah. Here, let me draw the set difference operation. Yeah. Yeah. Let me draw smaller. Yeah. All right. Still set A, set B. Yeah. A, B. Then, in set A, the difference, minus, sometimes people like to use this backslash as the set difference operation. Yeah. Yeah. Sometimes people use the minus, but minus, in order to represent this minus difference operation is a special set operation. Yeah. So there, many people use this backslash to represent the set difference. Okay? Yeah. In set A, you remove all the elements that belong to set B. Yeah. Okay? Remove all the elements that belong to set B. That's the set difference operation. Okay? In SQL, we use this except keyword. Except keyword. Yeah. But one thing to let you know, this except keyword may not be supported by all DBMS. Okay? Some DBMS may not support it, this except. Okay? Yeah, because MySQL does not support, or at least older version of MySQL does not support. That's except. Yeah. So in that situation, if it does not support, we need to get around it. Okay? We need to find a different way to represent the set difference operation. Yeah. Get around this. Yeah. I will show you how to get around. Yeah. Yeah. You can do it. Yeah. 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 Get around this except keyword. All right. Then the third one, set intersection. Yeah. So you know the meaning, right? Set intersection, the third one. Intersection. Okay? Yeah. A, B here. Yeah. So A intersect B. Yeah. That's the set operation. Yeah. But we know the meaning of set, in math, when we move to SQL context, we modify from set to multiset, right? Yeah. From set to multiset. Yeah. So in SQL, yeah, we have that set concept, but we have a more general multiset concept. Yeah. So we need to do things differently. Yeah. When you work on sets, no duplicate rows, that's the set case. Then with duplicate rows, that's the multi-set case. All right. So we need to have the multi-set operations versions. Yeah. All right. Condition, yeah. Later we will see that multi-set. Yeah. But there is some condition for set operations. When you apply these set operations on A and B, these A and B, they need to satisfy certain condition. Yeah. When we join two tables, we do not have any condition, right? Any two tables can be joined. We don't have any condition for table join. But here, when we apply set operations, then we have some condition. Certain condition. So we call it union compatible relation. Union compatible. Set A and set B, they must be union compatible. So what's the meaning of union compatible? Yeah, we just create a, special terminology for the condition. Yeah. All right. They should have the same attributes. Okay? The attribute list in these two tables should be the same. Yeah. Okay? Yeah. But the attributes appear in the same order in both relations. Yeah. The order of these same attributes should also be the same. Yeah. Then we call these two tables, they are union compatible. Then you can apply union operation, intersect operation, and except operation. Otherwise, you cannot. Yeah. Otherwise, you will get DBMS will find the error. Okay, so you will get an error message from DBMS. Not union compatible. Yeah. Right. Yeah. Then multi-set operations. Yeah. Multi-set, yeah. How to deal with the duplicate rows, multi-set. Okay. Yeah. So the operation names you modify slightly. Yeah. Union is the set version. If you want to get a multi-set version, you just add all. So called a union or operation. Except or operation. Intersect or operation. Yeah. So when you use the multi-set version, you need to keep the duplicate rows. Although you should not remove the duplicate rows. Keep the duplicate rows. Okay? Yeah. All right. Each tuple, duplicate or not, is considered as a different tuple. Yeah. That's our understanding. Understanding for the duplicate tuple. Although they are duplicate tuple, but you treat them as different copies of the same tuple, but in several different copies. Copy 1, copy 2, copy 3, and you treat them as the different objects. Different objects. Okay? Yeah. Yeah. So that's the multi-set version. Yeah. 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 Okay? Yeah. All right. So this rule, you need to keep in your mind. Right? Then I can ask you a question. All right. So here, suppose let me use the union example. Okay? Union example. Yeah. All right. All right. Yeah. Let's look at A union. Yeah. So do not use the math way. Let me use the SQL way. Okay. A. I just type the keyword union. Yeah. A union B. Okay. Yeah. A and B, they are both multi-set. Multi-sets. Okay? Yeah. So think about what should be the result. Yeah. So when I apply the set union operation on A multi-set and a B multi-set, yeah. A has duplicate rows. B also has duplicate rows. But here we do not use union all, okay? We use the union operation. We do not use the union all. So we should treat as set, right? Here, yeah, not multi-set. We treat as set. Yeah. Do you think the duplicate copies should be removed from A multi-set and B multi-set? Think about that. Do you think the duplicate copies, yeah, because we should use the set way, right? Set way, no duplicates are allowed. Yeah. Do you think we should get yeah, so there are several possibilities. Okay, several possibilities. Yeah. One is we get an error message from DBMS, rejected. Yeah. Rejected. That's one possibility. Another, yeah, not rejected. Yeah. So we, it works. Yeah. But A set is A set. In A set, the duplicate rows are removed. And in B set, also duplicate rows are removed. There, we just apply the set union on these two sets, yeah, without duplicate rows. That's another possibility. Okay? Then the third possibility, the same as union all. Okay? Yeah. Keep the duplicates same as union all. Okay? Yeah. Yeah. Think about this question. Yeah. Yeah. But to get the answer, we need to do some experiments. Right? Yeah. So we need to create, A table with duplicate rows, B table duplicate rows. Then we apply the union operation on them and see what's the result. Okay? Yeah. 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 All right. Yeah. So yeah. If you are interested, you can try it by yourself. Yeah. Then I will try by myself. Yeah. So I will let you know. Yeah. Yeah. So what's the result? Experiment result. Yeah. All right. So that's the second topic. Yeah. Yeah. Oh, yeah. Let's look at example. Set union. Yeah. All right. Yeah. Question. Make a list of all project numbers for project that involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. Yeah. Yeah. All right. Then, so two parts. So yeah, we want to separate. Yeah. So there are two cases. The first case, yeah. So we consider worker Smith, okay? Yeah. Employee, yeah. Employee. Those employee last name Smith, but in this round, this Smith employee, the role as worker, yeah, worker working on the project, okay? The second round, yeah, this Smith employee, same Smith, but this time work as a manager role, okay? Yeah, worker role the first time, manager role second time, okay? But we want to do the union operation, yeah, because either or, right? So now we, use the union operation to put them together. Yeah. That's the meaning of this question. Okay? Yeah. Let's do them separately, okay? Yeah. Then union operation. Yeah. All right. Yeah. Okay. Yeah. Let's look at the union part. Yeah. Distinct P number. Yeah. All right. Yeah. 3 tables: project table, works on table, employee table. Yeah. Yeah. All right. So 2 join condition: P number, P no. So join. Right. P number, P no, join these 2 tables. ESSN, SSN join these 2 tables. Yeah. Then, last name, employee. Yeah. This way, so that is the worker role. This employee plays the worker role, okay? Not manager role. Okay? Manager, then we need to use the department table. Okay? Department table, the manager's role. Okay? So the second round, distinct P number. Yeah. This time we need to use the department table. Okay. Not works on table. Works on table is for the worker. Okay. Yeah. For the employee as worker. Okay. So department table, not as the manager. Yeah. Then join table dnum equals d number. Yeah. Join these 2 tables. Okay. Manager underscore SSN equals SSN, join these 2 tables. Okay, all right. So then, the last name, Smith. Okay, so this time, this employee, Smith, plays the manager role. Okay, the different. Okay, yeah. All right, yeah. Then, union. Okay, then, to the union. Yeah. Here you can see, yeah. So here, let's discuss a little bit. Yeah. Because here we use the distinct keyword. So we remove the duplicates, right? Yeah. Before we apply the union operation, yeah, we use the distinct keywords to remove the duplicate rows. Then, no problem, okay? Yeah. Union, no problem, yeah. Conceptually, everything's all right, conceptually, right? Yeah. Set operation. Okay. All right. Then, so the question I asked you, in the previous slide. Yeah. Then, think about if we do not remove the distinct keyword. Okay. Yeah. Then, you may have duplicate rows. Yeah. So each table, yeah, each subtable, that's called a subtable. Okay. each one has the duplicate rows. Then the question, okay?
Are there other instances where we don't want to use a distinct word, or it's pretty safe to like always use the distinct word?
It depends. It depends. Yeah. So the basic principle is like this. If you do not use the distinct keyword, if you get basically the same thing, then you do not use. But if you get different result, then you need to use the distinct. Yeah. Because sometimes if we put a distinct, yeah, because when I did the grading before, many students, they like to put distinct, yeah, because they worry a lot. Yeah. But if you then you need to think about logically, even if you use the distinct keyword, but at the end you get the same result because the distinct, so you will run it slowly. Slower. Yeah. So distinct version, it runs slower than non-distinct version. Yeah. But if the result different, then you need to put the correct result as the higher priority, right? So you don't worry about the performance. Yeah. But if the result is the same, then performance is more important, right? Yeah. Yeah. The reason distinct because you need to sort, you need to do extra work, right? When you sort it, you do extra work. You need to use more time. Okay. Yeah. Yeah. So
here, distinct, there could be multiple different P numbers?
Yes, could be multiple. Yeah. Yeah, so think about it. We may have multiple employees with the same last name, right? Okay. So 2 different employees, they work on the same project. Do you want to show it more than once, right? Yeah.
We just want one answer or one.
Yeah, just one. Yeah. Okay. Just one. The project number. Why need to keep multiple copies, right? Multiple times the same project number. Yeah. 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 So. All right. Yeah. So because when I did the grading for many students, they want to be safe. Okay. Yeah. Yeah. So they want to be safe. So they like to put that distinct keyword. Yeah. Yeah. But in your real world situation, yeah, first you need to make sure the result is correct. Yeah. After that, you need to improve the performance. Yeah. Second round, yeah. First round, make sure the result is correct. Okay. Then the second round, yeah, especially when it's distinct, think about if you do not use distinct, do you still have the same result or different result? Okay. Yeah. Yeah. If same result, then you can remove it. If different result, then you need to keep it. Okay? You need to keep it. That's the general principle. Yeah. General principle. Yeah. But when I did grading, many distinct unnecessary. So usually I mark it out. So this distinct unnecessary. Yeah. It happens. All right. Yeah. So, okay, yeah, so here, yeah, the question. Yeah, 8.3, yeah, yeah, stream pattern matching. This topic we did it before, but here there is one slide, some little more information. Yeah, yeah. So I want to talk about the like operator. Yeah, a little more information. This slide. Partial stream matching, the like operator. Okay. Yeah. Special characters for pattern description. Yeah. All right. The percent sign replaces. Yeah, we use that arbitrary number of 0 or more characters. This, from left, from right. Yeah, including 0 and more. Yeah, but there is underscore replaces a single character. Okay. Yeah. Single character underscore. Yeah. Yeah, not that question mark. Yeah, single underscore. Okay. Yeah. That's quite different. Yeah, that's quite different. Okay. Yeah. 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 All right. The performance issues are here. Yeah, I want to talk about, because when you use the string comparison operator in this way, there is a potential performance slow down. Yeah, I need to explain a little bit. Okay. All right. Especially for large data amount. Yeah. Okay? Yeah. All right. So here I want to explain in this way. Yeah. Do not use this operator to do the string-based search. That will be very slow. Okay? Yeah. Yeah. Because this you can suppose you have some text body, okay, the content. You want to search, try to match a particular substring. Use this like operator. Okay. Yeah. If the text body part relatively large, when you do the search, relatively slow. You need to be aware of that. Yeah. Especially, you need to run this operation on many rows. Think about that. Large number of rows, and not just the one. Okay? Think about how slow it will be. Okay? Yeah. Then imagine a special situation here. Yeah. So that's why I want to explain this question. Yeah. It looks simple, but we know in our SQL operations, response time very important. Yeah. Response time very important. Yeah. Here, this could be a bottleneck of the response part. Yeah. So this, you use like operator, try to, match, large number of rows. Yeah. The text body relatively large. In that situation, it could be very slow. Yeah. All right. The reason is simple. First, we know string comparison slow, right? String comparison slower than numeric comparison. String, we use character by character comparison, right? Yeah. So much slower than the numerical comparison. Second, that in each text body, the block of text, okay, there is the block of text. You need to match the certain pattern, okay, certain string pattern, substring pattern inside that text body. You need to do a lot of comparisons, right? A lot of string comparisons, okay? But that's just in one row. Think about it, you have many rows, relatively large number of rows. How slow it could be, okay? Yeah. That means never try to use this operation to do the keywords-based search. Keywords-based, then it will be too slow, okay? Yeah. So that's why for the search engine, they use the pre-processing. Remember, I talked about the pre-processing idea. Long time ago, right? Yeah. Pre-processing idea. Yeah. Why people do pre-processing? Because if you compare using this operation, like pattern matching, even the regular expression way, yeah, the pattern matching way, yeah. These two ways, like operator, regular expression, directly, it would be extremely slow. That's why, in order to speed up, people use the pre-processing, convert string comparison to numerical comparison. Because after pre-processing, you will use the numerical numbers to represent keywords. The ID of each keyword, you can use a number, ID number. Yeah. Then you do numerical comparisons. Okay? Yeah. And you store the mapping results. Yeah. So actually, you just go through the mapping results. Right. The comparison part you did before the user submitted requests. That's the pre-processing. Before the user submitted requests, pre-processing. Okay, yeah, yeah, yeah. So for that, you know, yeah. So when you use this feature, yeah, you need to consider more related to the response time. Yeah. All right. Yeah. Then specific escape character. Yeah. Yeah. Sometimes you need to escape some special character. Yeah. But here in SQL, so when you use the like operator, yeah, the rule is different. The rule is different from we use the backslash, remember? Yeah, backslash, yeah. Here, although you can use backslash, but you need to declare it. Before you use it, you need to declare it. Yeah. So here, an escape character is specified after string using the keyword escape. Yeah. So first you use this keyword to declare some special character. You want to use it as the escape character. Then you use it. Yeah. For example, yeah, this backslash, right? We need to declare escape, then this backslash symbol. After you declare it, then you can use it as the escape character. Okay? Yeah. Yeah. That's for this like operator. Okay? When you use this like operator. Yeah. But when you use regular expression, the rule is different. Remember? Regular expression, we do not use escape keyword to declare it. Yeah. We use backslash directly. Yeah. Because that's the escape character. Regular, yeah. All right. Yeah. So that's this topic. 8.4 insert statement. Yeah. Yeah. So here I do not have, yeah, I only have a few minutes left. Yeah. Let me talk about a simple case. Yeah. Yeah. Simple case I can finish quickly. Insert, the syntax very simple. The next I leave the relatively hard case next time. Yeah. The simple case, straightforward. Yeah. Insert statement. Yeah. The simplest form is used to add a single tuple. Every time we insert just one row into the table. Yeah. That's easy. Yeah. Yeah. The relative hard case is the multiple row insertion. Yeah. So we talk about that next time. Multiple row insertion. The single row insertion, yeah. Yeah, syntax very simple. Specify the table name, list of values for the tuple. Okay, yeah. So, two versions here. Although the single tuple insertion, but there are two versions. Okay, all right. All right. The values should be listed in the same order in which corresponding attributes were specified in the create table. Yeah, because same order. Yeah. So here, this rule is when you want to omit that whole list, use the star. Yeah, omit. Yeah. So we insert. So if you use the same order, then you don't need to specify it. Okay? Yeah. So let's look at insert into table. All right. Then, because you want to use the same order here you want to use the same order, then you do not need to list all those field names. Okay? Yeah, so you can omit all the column names or field names. Then you just, after the values keyword, parenthesis, yeah, comma separated, the tuple value, yeah. So those values, yeah, you need to follow the same order. Then you do not need to specify the column names, 1, 2, 3. Okay, you save it. You save it. Yeah, that's the first version. First version. Yeah. All right. Second version, yeah. Now, you do not specify, because remember, we talk about the null value and the default case, right? Remember? Yeah. So here, when we insert rows, we need to consider the case. Yeah, here I have, less than 5 minutes. Yeah. So here, consider the 3 cases. Yeah. One case is remember, auto increment primary key. Auto increment primary key. Then another case, null value, because for null values are allowed, right? And the third case, default value. Default. Yeah. When these 3 cases could happen, that means some of the fields can be omitted. Some of the fields related to these 3 cases could be omitted. Yeah. Because auto increment, DBMS can generate the value, so we can omit. Okay, all right. Null value, if we omit, null value is used, so we can omit those fields. All right. Default, because the default value provided, if we omit, the default value is used, so we can omit certain number of fields. Yeah. In that case, then. Second form of insert. Yeah. All right. Allow users specify explicit attribute names that correspond to the values provided. Yeah. Then we only need to write those attribute names that we do not want to omit. Okay. Only the necessary part. Yeah. The unnecessary part, those if we can omit, then we do not write. Okay. All right. So let's look at this version. Value must be include all attribute with not, if not null, you cannot omit, okay? If you put the not null constraint, then you cannot omit specification. And no default, if no default value, yeah, and no default value, yeah, if default value you can omit. So if you put a not null constraint and you do not provide the default value, for that case, you have to provide your own values. Yeah. All right. Attribute with not allowed or default value are the ones that can be left out. Okay. Yeah. Here I didn't mention the auto increment. Auto increment, the third case. Okay. Yeah. All right. Look at the example. Insert into employee. Then you specify these 4 field names. Yeah. In any order you like. Here you can change the order in any order you like. Okay. Then the values, but value you need to, make sure the one-to-one correspondence relationship. Okay. Yeah. Not mess up. Okay. Wrong mapping. Yeah. So you have to, the first one maps the first one, second maps second one, third, and so on. Okay. Yeah. Yeah. The remaining, yeah, because there are several fields we didn't specify here, yeah, because we allow null value or we have the default. We have the default values in our table definition. Yeah. Auto increment, employee table, we do not use auto increment. Yeah. So you do not consider that case. Yeah. All right. Yeah. So, okay. Yeah. So let's stop right here. Next time we talk about the multi-row insertion. Then there are many technical questions I need to explain. Yeah. 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 All right, that's it. Yeah.